In this video, we will install the fluxAI on the Forge user interface and review the settings and tools this interface provides us. This AI is completely free and without any limitations, and you can easily use it. If you don't know what Flux is, I've created a separate video where I fully introduced this AI, reviewed its different versions, and compared it with its competitor, MidJourney. I also mention an important point at the beginning because many people have asked about it. If you run the fluxAI on your computer, it's free, with no limitations or censorship. However, in that video, I introduced several websites for those who didn't want to or couldn't run Flux on their computer. These websites are not free and have limitations. Alright, let's move on to installing Flux on the Forge UI. Stay tuned with Skillura. To run Flux on the Forge UI, you need to install the latest version of this interface or update it. If you're using an older version, as previous versions do not support Flux. If you're using an older version, you can update it using the method I'll explain. Navigate to the directory where Forge is installed and enter the main folder. Click on the address bar, type CMD, and press Enter. In the command prompt window, type git pull and press Enter. Wait for the update to complete. If you don't have the Forge interface installed, you can use this simple method to install it. First, go to the developers page for this interface on GitHub. I've provided the link in the video description. Navigate to the installing section. Use the link there to download Forge. I've already downloaded it. After downloading, extract the zip file. Now, run the Forge UI using run.bat. At first, you'll need to wait a bit for the required files to download. If this method doesn't work and you encounter an error, I've previously created a tutorial on manually installing Forge, which you can watch via the link displayed at the top of the video. Now, let's move on to downloading the models and installing Flux. You'll need a graphics card with at least 8 GB of VRAM to install Flux. In my video about Flux, I explain the system requirements for running this AI in detail, so feel free to check that out. First, we must download the text encoder, VAE, and Flux files. If you've already installed Flux on comfyUI, there's no need to re-download the files. Place the files you previously downloaded in the paths I'll explain. To download the text encoder, go to this page on the huggingFace website. From this section, download the clip.L file. After downloading clip.L, you need to download the T5XL file. Download this file if your system has at least 32 GB of RAM. Download this file if you have less than 32 GB of RAM. Place the files you downloaded in the specified path. In the second step, you need to download the VAE file. To download it, go to this page on the huggingFace website. Download the ae.safetensors file from this section and place it in the path specified. Finally, you need to download the main Flux file. You can download the original Dev and Schnell versions using the link in the description if you have a high-performance system. However, if your system cannot handle the main Flux models, you can download the optimized, lightweight version of Flux from this page on huggingFace. Download version 2 of the NF4 Flux from this section to do this. After downloading, place the file in the path specified. After completing these steps, launch Forge. The new version of Forge has some changes compared to older versions. For example, a UI section has been added, which includes preset configurations. For those who want to use stableDiffusion versions 1.5 or 2.1, you can enable the SD option. If you want to use the XL versions of stableDiffusion, you must enable the XL option. To use Flux, simply activate this option. Set the checkpoint to the Flux model you downloaded, and that's it. Now, let's run a test. I'll paste a prompt I prepared earlier into this section. Set the distilled CFG scale to 5. Leave the other settings as they are, and click Generate. If this is your first time clicking Generate, you'll need to wait a bit for the models to fully load. This process takes some time initially, but will be faster in subsequent runs. Here's the result. All right, let's test it again. This time, I'll also generate an output for this prompt using the stableDiffusion model to compare. I'll set the UI to XL and the checkpoint to the realistic vision model. I'll also match the width, height, and CFG scale settings exactly to the Flux model. As you can see, the eyes, necklace, and hands have issues. Overall, the output isn't excellent. This time, I'll change the sampling method and schedule type to see how the output changes. Again, the result wasn't satisfactory. For high-quality outputs with the stableDiffusion model, you need to experiment with various settings and models, which I'll cover in future videos. For those new to working with these models, I should point out that stableDiffusion and Flux are two completely different AI models. Now, let's go back to Flux. I'll set the configurations to Flux mode. This time, I'll increase the distilled CFG scale so that my prompt has a stronger influence on the final output. Or, in simpler terms, so that the final production is closer to my prompt. Here's the final output using the Flux model. Stay with us as I briefly explain the settings and features of Forge. If you select the Flux option from the UI section, several additional options will appear compared to SD and XL. The Diffusion in low bits option allows you to run models with lower computational precision. This feature reduces GPU memory usage and increases processing speed, especially when working on limited hardware or graphics cards with low memory. I recommend keeping it on the automatic setting. The swap method option determines how the model's data is managed between GPU and RAM. Q. Data is loaded and processed sequentially, which is suitable for systems with limited memory. Async. Data is managed asynchronously, which increases speed but requires more robust hardware. This setting helps optimize system performance based on hardware resources. The swap location option determines whether the memory used for transferring model data between the GPU and other resources should be CPU or shared. Data is moved to the system's RAM, which is suitable when the GPU does not have enough memory. Shared. Uses shared memory between the GPU and the system, which can increase data transfer speed. This setting optimizes resource management in systems with limited GPU memory. The GPU weight setting allows you to specify the amount of GPU memory allocated for storing model weights. I recommend always leaving some GPU memory free for processing and calculations. Allocating all memory to model weights might result in errors or program crashes during image generation. Here, we have tabs designed for specific purposes. Let me explain the function of each one in simple terms. You can generate an image from text by entering a prompt in this section. Anything you don't want in the image should be written in the negative prompt section. From here, you can select ready-made styles. These preset prompts can be very helpful and significantly impact the final output. In the sampling method and schedule type sections, you can choose how the model processes the image. Using sampling steps, you can decide how much time the model spends processing the image. The fewer steps, the faster but lower the quality of the image. Conversely, more steps result in slower processing but higher quality images. The Hires Fix section is used to improve the resolution of images at larger dimensions. The Refiner tool enhances the quality and details of the image. Fixing flaws, increasing resolution, and correcting proportions create a more professional final output. For the best results, combine it with Hires Fix. Note that enabling this may slightly increase processing time. Here, you can specify the dimensions of the image. The CFG scale option determines how closely the model adheres to your prompt. However, if you are using Flux, the story changes slightly. Here, the CFG scale is linked to the negative prompt, and if it's set to 1, it is disabled. You can use the distilled CFG scale to control how much the prompt influences the final output. You can use the regular CFG scale in the XL and SD settings. The seed option allows you to reproduce the same image with the same settings. If you're satisfied with a result, note its seed. If you want a random image, set the seed to -1. For consistent projects, use a saved seed. This tab is designed to modify or enhance existing images. You can upload an image, and with a new prompt, the model will reconstruct the same image with the desired changes. I'll explain this tab and others in detail in future videos by working on various projects. This tab includes tools for enhancing the quality of images. Suppose you have an image generated with stableDiffusion or Flux. In that case, this section provides details such as the prompt, model settings, and parameters used. This tab is used to combine multiple models into a new one. This tool is helpful if you want to integrate specific features of several models into one. This section manages all Forge's general settings, such as the hardware in use, default model parameters, and workspace configurations. This section is for adding new features to Forge. You can add functionalities like specific models or more advanced tools by installing extensions. Unlike Automatic 1111, some commonly used extensions are pre-installed in Forge's interface, and you can access them here. If you enjoyed the video and found it helpful, please like it and subscribe to the channel for more tutorials.